Good evening once again. Welcome to today's session. This session of research methods brings us to uh, the second topic, the quantitative part, that's hypothesis. I know we are familiar with this particular topic because we learned it last semester during the quantitative methods. All right. Before we commence, I want us to start solving tutorial sets on data types. Okay, so without wasting much time, I will share that tutorial set for us to discuss. Okay, so can you see the questions now? The tutorial set, can you see it?
Yes, please.
Okay, so let's start. So this is how we will do it. For question 1 and question 3, with their alternatives, all of them, question 1 and question 3, or all the alternatives A to D, we are going to read the possible answer and mention the data type and the level of measurement for that particular option. Okay, so first question, which of the following variables is an example of ordinal variable? Here, we can choose our answer straight based on what we learned in the section 1, that's the data types. But here, I want us to determine or identify the data type and the level of measurement in all the alternatives. So the first one, the grade obtained, which of the following variables is an example of ordinal variable? A, the grade obtained by a student in research methods. B, the time it takes you to write a test. C, the geographic region of the country in which you live. D, the marks scored by a student in an exam. Right? So please, what is the data type for A and its level of measurement or the scale of measurement?
Okay, the grade obtained by a student in research methods, I would say it's a categorical one and it can be ordered, so it's odd now.
So categorical ordinal, all right, so B.
Yes. The time it takes you to write a test. The time is numerical and it's ratio.
All right, so C.
The geographic region of the country in which you live. So it is categorical and then nominal, cannot be ordered.
Yes, so we cannot order the geographic region. Right, D.
The marks scored by a student in an exam.
Okay, so
the marks. I think it's numerical and then interval. Or by a student, then it is ratio.
Ratio, yes, because the one person can get 0.
Yes.
All right. So what is now? We will come to the solution or the answer to the question itself. Now, which of the following variables is an example of an ordinal variable? So which of the alternative is the correct answer here? They are asking for ordinal variable in the one that can be ordered.
A, the grade of
yes. So you can order. So in university we have A, B plus, B, C plus, C, D plus, D, E, and F. You get it. Now let's come to question 2. Which of the following is most likely a continuous numerical variable? This one from A to D, they are all numerical, but they are asked which one is most likely. Now I'll count in number of gallons of paint per chip. That one is not part. The number of grams of the powder, that one is not part. Now you might think the answer is C because continuous, like continuous numerical variable. But this one, they didn't say population of Accra. They were specific. They mentioned the particular year. So they said population of Accra in 2005 stagnant. That population for 2005 is stagnant. It's fixed. It doesn't change in that particular year. It's only changed, let's say, next year or something. So that one is not part. But the number of kilometers of highways in Ghana is the continuous numerical variable. So that's the answer. Question 2 is D. You get that part. D for dog. D for dog. That's the answer.
Yes, please.
Okay, question 3. Which of the following is a nominal variable? Okay. So which of the following is a nominal variable?
Cannot be ordered.
Yes.
See, the blood pressure levels of CEOs.
Is that A the answer? Hello?
Yeah, I said it.
Nominal variable. But do you know, like, blood pressure? But for me, I know blood pressure can be measured. Well, they are in high, low, and normal. So you can measure them. So it can be low first. From highest to lowest. That's any order. It can be high, normal in the middle, then low at the bottom. So it can be ordered. So blood pressure can be ordered. Blood pressure levels can be ordered. High, low, normal. So high, normal, low. So if it is ascending order, the first one I mentioned was descending from highest to lowest. But if it is ascending from lowest to highest, it is low, mid, normal, but high. So the blood pressure levels of CEOs can be what? Ordered. Okay. B. The bank account balance of the bystander. This one you don't have to worry yourself. For this one, it is bank account balance. So this one is talking about numbers. And the question that you are asking, nominal variable. Nominal is an categorical. So when you see numerical question like B, numerical option, don't even venture to think about it because it's outside the box, right? Okay. So let's look at option C for this one. Okay. And we are saying rating of firms. So what is that one too? Rating of firms. Data type.
In media, it can be ordered.
It
So
can be
it falls under categorical ordinal.
Good. So categorical ordinal. Now D is talking about the eye colors of what? 5 students. So this one is categorical and what? Nominal. Because how are you going to rate or order eye colors of 5 students? So D is the answer. That's the nominal variable. Are you okay?
Yes.
Okay, 4. Read the question 4 for me.
What is the correct order of data from weakest or lowest level to strongest or highest level?
Okay, so with this one, in the last video, I gave you mnemonics for you to recognize the order of data from weakest or lowest to strongest or highest. Oh, I said something. And I gave you this. I gave you this. NOIR. So this one is from what? Lowest to highest. So looking at this NOIR, what is the answer from this alternatives? Looking at the abbreviations, what will be the answer?
A.
A, yes, nominal ordinal interval ratio. So when they ask from strongest to what? Weakest, you will turn this one. So that one is going to be RION. So this one is from strongest to weakest. This one is what? weakest to strongest. Are you okay?
Yes, please.
Number 5.
Dr. Ohenia Sare graduated from Warwick University with a code value equal to 1, while Professor Boateng graduated from Manchester University with a code value equal to 2. The scale of measurements likely represented by this information is
So it's
A.
what?
Nominal, B. Ordinal, C. Interval, D.
So
Ratio.
what would you answer? But what would you answer? And I 4. What would you answer?
Which question?
5.
Hey, Bozu. That's question 5.
I'll go for ratio.
Ratio. Why?
Because of the core value of 1 and the core value of 2.
It's not called code.
Sorry, code. With a code value of 1 and the code value of 2.
Okay, Agnes, what would you answer?
I think
You think or that's the
categorical
answer?
ordinal B.
B. Okay. So let me come in. Now, you are choosing ordinal ratio because of the number 2 you are seeing. Bear in mind, they are only representing the number with something. Dr. Hinasai graduated from what? Warwick or something, I don't know the word. University with a code value. So they are just coding it. They are just giving it a code. You see, sometimes when you are filling a questionnaire, you see the male, they will code the male to go at 0, female to 1. That does not make that particular thing about quantitative data or something. The 0 is representing female, so it's still the English or the statement, so it's still qualitative. So this one is not numerical. So therefore, this one they are just coding it. They are just representing the number 2 and 1 with the universities. Because Professor Boateng also graduated from what? Manchester University with a code. So this one they are just coding them instead of representing them with their names and with their universities. They are just what? Coding. So the number here, shouldn't that number deceive you? Shouldn't let that number there deceive you? So the answer is nominal because it is categorical and it cannot what? Order. It cannot be ordered because you cannot tell me that one university is what greater than other or the other one professor or is good than the doctor. No, it's categorical and nominal. So it right. So
So the answer is A.
yes, nominal. They were asking for the scale of measurement or level of measurement. They didn't ask for data type. By the data type here is categorical because ordinal moves with one. Categorical, nominal moves categorical. You get it?
Yeah.
Okay, 6. Read that. Read it for me.
The type of variables which produce responses that belong to groups or categories, such as responses to yes or no questions, are called.
So this one A to C. So this one, what is the answer?
Discrete.
Eh?
Discrete numerical variables.
Discrete. Is discrete part of the variables? We only have 2. We have categorical and numerical. And I don't know of that discrete, but I didn't see it up there. Okay, Agnes, what was the answer?
Please, I'm coming, I'm reading. The type of variables which produce responses that belong to groups or categories means that it's categorical variables or
He said it's what?
categorical.
Perfect. Very, very important. Good. So therefore, it's categorical because they are saying that belongs to groups or categories such as responses to yes or no questions. So last week, no, in our last meeting, I told you that whenever you are asking questions or you are making inquiries, and then the response that will be given are in what statement, or they are just the English, not numbers, they are the English. That one is what qualitative, and the qualitative is what categorical. And if the response demands what numbers, they are numerical. But this one, they are saying yes or no. Yes or no is what in statement or is the English. So this one is categorical, right?
Okay, sir.
All right. So 7. 7, please read.
I'm coming. Which of the following statements is or are incorrect?
Yes. Okay.
Ordinal data may be described as qualitative.
Is that one correct or incorrect?
It's correct.
Correct,
It
because
is
qualitative is under what? Qualitative or categorical, and ordinal is under what? Categorical. Correct. Okay, B.
B. Nominal data may be described as quantitative.
Is that one
False.
good? So that's the answer. The moment you meet the false, that becomes the answer. But
A
nominal,
categorical.
yes. So B is the answer. B is the answer. The moment you said false, so is the answer, because we are looking for only one answer. You get it? So the rest are basically true. Phenomena is under what? It's a level of measurement or scale of measurement for categorical data. And the categorical data is what? Qualitative, not quantitative. 8.
8. A variable is classified as ordinal if A. There is a natural ordering of categories. B. If there is no natural ordering of categories. C. If the data arise from continuous measurements. And D. If the variable is tracked over a period of time.
What
A
is the answer?
variable is classified as ordinal.
What is the answer?
A.
A. Good. So the variable is classified as ordinal if we can order them. It has intrinsic ordering. So A is the answer. 9.
9. Which of the following statements involve descriptive statistics as opposed to inferential statistics? A. 30% of the 380 marketing leaders prefer double colon articles. B. The police service reported that Kumasi had 1,850 registered gun dealers in 2013. C. The fire service sampled 425 fire disasters in order to estimate the percentage due to job-related stress. And D. From a sample of 350 players, a magazine reports that 23% of players' parents did not play ball.
So this one,
The
first of
other
all, okay, you're not done. Read it.
I said I didn't understand.
Right down. Okay, so we are saying So you have to understand the word of what descriptive statistics and what inferential statistics. Now we are saying descriptive statistics as the name implies. You get it? So this one you are just describing the scenario. You know the facts. You get it? By the inferential, that one you are, I don't know how to put it, based on a sample, you are generalizing for the whole population. You get it? So looking at A, for instance, is what? Inferential. 30% of the 380 magazine readers prefer double column articles. Yeah, so this one you use some portion, you use sample to conclude for the article population. You get it? So the C2 was about sample. The first service sampled 4255 disasters. D2 was what sampled from a from a sample of 350 players. The magazine reports that 23% of players currently did not play ball. So do you get it?
Yeah.
He said
So the answer is B.
B, because you see all the three A, C, and D are talking about what? Sampling.
Yeah.
And that's inferential. Inferential is when you use sample to generalize something for the whole population.
Okay.
You get it?
Yeah.
So let's move on to the last question. Then we start the topic for the day. So question 10.
An automobile insurance agent believes that company A is more reliable than company B. Which level of measurement does this information represent?
So an automobile insurance agent believes that a company is more reliable than believes that company A is more reliable than company B. Which level of management does this information represent? Okay, answer. But for where are you? 994. And the rest. Only Agnes is talking. So Agnes, what's the
answer? Nominal.
Try again.
Ordinal.
Why? Ordinal.
Because they've been able to group, or they are able to tell which one is more reliable than the other.
Perfect.
A form of example.
Very, very important. Very, very important. So if this that automobile insurance agent is trying to rate company at A above company. So he is trying to say that the company A, you can rely on company A more than what company B. Meaning he placed company A above company B. So before the ordering was meaningful. It was not meaningless. You get it? Yeah. So I was saying you the prayer set, you guys should just try hands on it, find more questions on it. You will get it. Because the thing is not difficult, but it can be difficult sometimes. This particular data type is not difficult, but it can be difficult at times because you might miss a whole lot of stuff. You get it? Okay. So let's move straight to today's topic. Hypothesis. Can you see the screen now?
Yeah.
Can you see the screen?
Yes, I can see it.
So today we'll be starting with hypothesis. And I hope we know hypothesis from last semester's course. So we are saying hypothesis. Can you see the slide?
Yes, I can.
Okay. So we are saying hypothesis is a statement, claim, or assumption about population parameter, such as the average, variance, standard deviation. A hypothesis can be a statement or a question. Yes, it can be a statement or a question. All right. So let's move on to the whiteboard so that I explain more to you. So you are saying hypothesis is a claim or assumption about a population what parameter. All right. As you see the whiteboard for some information. Now I have a particular definition here, so let me type that onto here. So hypothesis is the what? Authoritative. Authoritative statement put forward by a researcher because it is either believed to be true or forms the basis for the argument, though not proven. So we say something and we believe that that thing is true, although it's not proven, but we are saying you claim that particular statement or question is what? True. You get it? And we are saying it's also the status quo. It's also the status quo. It's also called the status quo. And I hope you know the definition of what status quo means. I mean the current situation, what is happening now. That's the status quo. You get it?
Yeah.
Oh, okay, sorry. This one is this definition is for null hypothesis. All right, sorry. So as I said, the hypothesis is just I read earlier. Hypothesis is a claim or assumption about a population parameter. So the hypothesis, you are making a claim or assumption about the whole population before you take samples and decide on it or conclude and make your decisions. And we are saying we have two types of hypothesis. Sorry, I type this one as hypothesis. This one is non-hypothesis. So we are having two hypotheses. You get it? Two hypotheses. The first one is null hypothesis, and the second one is what? Alternate hypothesis. So the null hypothesis is represented by what? HO or H naught. So H or H naught. You get it? So that's why we return as. And I think it's authoritative statement put forward by a researcher because it is either believed to be true or forms the basis for the argument. Do not prove it. So it's also called a status quo. You are saying something. You claim that this thing is true, though not proven, but still you are saying it's true because it's the current what situation for the status quo. So we are saying that we have signs contained in what the null hypothesis. We have signs contained in null hypothesis. So we are saying it contains equality sign. You get it? It contains the equality sign. Equality sign. So less than or equal to, greater than or equal to, and the equal to sign itself. So less than or equal to, greater than or what, equal to. You get it? So when you see anything and these signs are key, it's talking about what? The null hypothesis. And we also have some English words. We have some English words here. When you see them in hypothesis question, it will help you identify that this one is what? Null hypothesis. So we have the English words. So first of all, we have the at most. You get it? At most. And at most is which sign? Hello.
At most, it means that you can't exceed it.
So
So
it's which sign?
than or equal.
You said
Less than or equal to.
less than or equal to. Perfect. Perfect. So less than or equal to. So what about at least?
Greater than or equal to.
Yes. So at least the minimum should be this. So at least it's greater than or equal to. Okay. Then we have these words here. We have is it means equal sign, not different from. That one too is what? Equal sign. Was equal sign of equal sign. We have performs. And you see performs to talking about the null hypothesis, equal sign. And we have within. Within two is less than or what? Equal to. So within means it's within this range. So within two is what? Less than or equal to. Okay, so these are the words, English words that will help you identify that a particular hypothesis is null. Do you get it?
Yeah.
And with is because it's talking about the population parameter, we use the mu, the mu, this sign, mu, this sign. Do you get it? We use mu. Now, if just discuss the first type of what? Hypothesis, that is the null hypothesis. Now let's move on to the second type of hypothesis. That's what we call HA or what?
Alternative.
Alternate hypothesis. So the alternate hypothesis. That one is represented by HA. HA is represented by HA. Represented by HA. And we are saying is the opposite of what? Null hypothesis. So is of null hypothesis or HA. Okay, so this one we are saying that is the opposite of null hypothesis. And is the one it seeks to challenge null hypothesis and it's called the researcher's hypothesis. So this one it challenges the status quo because the status quo is a null hypothesis. And the ultimate one challenge it. So if null is saying that something is equal to something, alternate will say that oh, it's not equal. If null is saying this one is less than or equal to the other one, less than or equal to the other one, alternate hypothesis will say opposite of it, and that one will be greater than. So that one too, it's never contained the equality sign. It's never contains the equality sign. It's never. contain the equality sign. So there's no equal to in this equality sign. So this one is just less than, it's just greater than, and just not equal to, not equal to, equal to sign, then equals it. That's why we call the not equal to, like this. Okay. So here I have the English words as here as well here. So the English words. So that one too, when you see above, it means what? Greater than. Can you hear me?
Yes, I can.
Okay. When you see below, it means less than. When you see exceed, exceed is what? Greater than. More than, the sign itself is there, less than is there. Different from. So you see, this one was not different from, it gave us the equal sign. So if something is different from, then we are not expecting equality here. So different from, A is different from B. It means they are not equal. So this one will give us not equal. You get it? So we have more than, less than, younger than. Younger than means what? Less than, younger than. When you're reading something in hypothetical, you come across younger than, it means what? Less than. So basically, this is what we call the what? Alternate hypothesis. It challenges the status quo. If the status quo or the null is saying it's B, only alternate hypothesis will say that it's what? A. You get it? Now, we have a tail of text. We have tail of text. So we're having tail of text. So we have the first one to be what? One tail text. And we have what? Two tail text. And with the one tail text, with the one tail text, with the one tail text, it's having the less than or equal to and the greater than or equal to and stars. But the two tail test is only when you see what? Equal sign. You find it to be two tail test only if you see the equal sign. Do you get it? And the one tail test is when your HO is such that mu is less than or equal to something, greater than or equal to something. That one is talking about one tail test. But when your mu or not is talking about equation, I mean equal sign, it means we are dealing with a two-tailed test. We are dealing with two-tailed test. We are going to deal with a two-tailed test. Right. So having explained this, do you have a question for me? Because I would like us to visit the slide and solve some two or more questions there before we continue. So do you have a question for me?
No, please.
Good.
No question.
No question. Okay. Okay. So how can you see the slides? So remember this one, as I said, the one tail test is when the mu is less than or equal to or greater than or equal to. But the moment you see equal sign, then
let me write it down.
okay. The moment it talks about equal sign, bear in mind that it's talking about a two-tail test. So for lower tail test, when your null hypothesis is such that mu is greater than or equal to something, and your alternate is less than or equal to something, that one becomes less than, only less than. HA is only less than something. Mu is less than something. That one becomes a lower tail test. For upper tail test, when our HO is less than or equal to something, and our HA is only greater than to something, then we see it what? Lower or upper. But the moment we see it to be equal sign, then minus 1.
It's a tilt.
So let's move on to the steps involved in solving hypothesis question or something. Yes. We have 4 steps also. So let's do them one by one. The steps involved solving hypothesis. So first of all, we are saying formulate your what? Now and what? Alternate. Now, the first step involved in solving hypothesis is saying we should formulate our null hypothesis or alternate hypothesis. And that one is the crucial aspect. That one is what the most important aspect. So with this one, you are formulating a null and alternate hypothesis to see that if your hypothesis is a what? One tail test or what? Two tail tests.
Two tail test.
You get it?
Yeah.
So that's the first step. You formulate your null and what? Alternate hypothesis. So I'm having some examples in the slides. Let's go back to the slides and solve for it before we continue the steps involved. Okay. All right. So hello.
Yeah, hello.
Yes, can you see the slides?
Yes, please.
So we are saying that let's find the HO, that's a null and alternate in your following statement. So read the first one.
Nescafe Ghana claims that since the population mean please, it's below. Can you scroll it up a little?
The answers are there. That's what I don't want to show.
Okay, so then fine. Nescafe Ghana claims that since the population mean filling weight is at least 3 IB per can, consumers' rights are protected.
Okay. So with this one, I give you some English words. That of null and alternate. I give you English words. So which English words relate to English word here relate to HO or HA?
I'm seeing at least.
At least. So where do you find that one? Is it in the null hypothesis or alternate?
It is in the null hypothesis.
So if it is null, the null is talking about the HO, right?
Yes, that the claim is right.
The claim is right. Good. So formulate that one for me. So our HO is such that mu is at least
is greater than or equal to H.
Is greater than or equal to H, right?
Yes.
It's equal greater than or equal to 3, at least 3.
Okay, so
HO is such that mu greater than or equal to 3. So if mu is saying HO is saying mu is greater than or equal to 3, what will be HA? Because since HA challenges the HO.
Then it will say that mu is less than or equal to 3.
Less than or equal to.
No, it will be less than.
Yes,
3.
I said the alternate hypothesis never contains the equality sign, so it's only less than.
Yeah.
So that's what we are seeing here. Okay. Read the second one.
Max Flight uses a high technology manufacturing process to produce golf balls with a mean driving distance of 295 yards.
So which one? How will you formulate your null and hypothesis?
This one, they are not claiming anything.
That
They are not making any claim.
they are claiming something.
That Max Flight uses a high technology manufacturing process.
I think they produce golf balls with a mean driving distance of what? 295. So population mean is what? 295. So it means it is equal to. So if it is equal to 295, then it means what? It relates to 80. That's a null hypothesis. That is where we find our equality signs.
Okay.
So to be HA is such that mu is HO is such that mu is what? Is equal to 295. And HA is such that mu is not
equal to 295.
Yes. Okay. So then according to you, with that
according to the CEO, the new BMW car can run more than 24 miles per gallon. More than,
yes. So more than is what?
More than is please hold on. Is HA. Oh.
More than, it means there is no equal, it's not more than or equal to, it's strictly more than. So
it's
more than
HA.
24. Yes. And we are saying the HO challenges the HA challenges the HO. So if HA is saying mu is greater than 24, definitely HA mu will be what? Less than or equal to what? 24. Do you understand?
No, come again.
You said it yourself that the more than is what?
HA.
HA. Because it never contains equality. So it's solely more than, right?
Yeah.
No less than or equal to. It's only less than, greater than, more than. And I say more than is HA. And I'm saying HA, they are saying that it's the opposite of NAV. It challenges the NAV. That's the status quo. Right?
Okay. Yeah.
Yes. So it challenges the HO. And now HA, which challenges the HO is saying the mu is more than 24. And it is always the opposite of what? HO. So if this one greater than 24, then HO will be the other way around. That's the opposite. Less than or equal to.
Okay, yes, understood.
Thank you.
So the formulation will be HO mu is less than or equal to 24 miles, and then HA mu is more than 24 miles.
Greater than 24. Precisely.
Yeah.
Very important. Let's move on. Okay. Ghana Telecom manager thinks that customer monthly cell bill average not at most 52 cedis per month. So forget about the not there and let's deal with the words that you see.
Please bring it up small. Ghana Telecom Manager. Okay. Ghana Telecom Manager thinks that customer monthly cell phone bill average not at most 52 Ghana per month.
Forget about the not then forget about it. So which word I see?
At most means that less than or equal to, meaning that HO is less than or equal to, making the HA greater than.
Exactly.
So HO mean is less than or equal to 52, and then HA mu is greater than 52.
Okay, that's it. Yes. The minimum wage.
The minimum wage in Ghana this 2015 is not at most 6 cedis. Not at most. At most means that the HO mu is less than or equal to 6, making the HA greater than 6.
So when you are reading it, when you want to formulate your hypothesis and you come across not, never mind that not.
Okay. Suppose that we want to test the hypothesis that the climate has changed since industrialization. If the mean temperature throughout history is not as improved as 50 degrees, what is the null or and alternative hypothesis?
It's not as improved. So if it's not as improved, there are what signs that
You said,
they are saying that the history is not improved. So what will be the sign? If it is not it's not as improved, then it means it's still
it's the same thing.
below each range or something. You get it? If someone wants you to, it means the person wants you to move forward, right? But this one, they are saying it's not as improved as 50 degrees. So even it's almost the same thing or below that. I trying to get that something.
Yeah.
Right. So the hypothesis, the HO will be what? The X.
Less than or equal to.
Is it? Sorry.
I'm saying that the HO will be less than or equal to.
Yes. So the H
making the HA greater than.
50. Good. So that one is here. You get it?
Yes.
So that's the first step you have to go through. You formulate your null and alternate, and that's the most crucial part. That place is at the difficult parts of the question because the rest are parallel, they are simple. You just have to capture the formulas and stuff. But with this one, if you misbehave, the work will be wrong because your conclusion, your decision will be on this null and alternate hypothesis. Do you get me?
Yeah.
All right. So let's move on to the whiteboard so that I'll explain with the next steps. Okay, so the second step, we are saying that to do what? Calculate the test statistics. Calculate the test statistics. You get, and we're having two of them. We're having T test and what? Having T test and what? z-test. Hello, can you hear me?
Yes.
And research methods, most of our questions will fall under what? Z-test. So forget that it will fall under t-test. So forget that about z-test. And we are saying that we use t-test. We only use t-test with t-test if your n is what? Less than 30. What is n? What do you represent by n? Hello?
I'm here.
I say, what do you represent by n in hypothesis?
Mu.
And mu is that you.
Okay.
Mu is this sign. So less than 30. N is what the sample size. You get this now?
Yes.
Yes. And we use z-test. So we use z-test when your n is what? Greater than or equal to what? How large is your large? How large is your n or something? That's why they say how large is your n or so. So your n is large if only it's greater than or equal to 30. And your n
Okay.
is small whenever it's less than what? 30. And in research methods, we are going to use what? The T test. Most of them will be on T test. All right.
Okay.
Good. So I think from here I have to give you the formula for the T. So it is what? T n minus 1 is equal to what? X bar minus mu bar minus mu, sorry, not from the mu bar. All over the x standard deviation. All over what? Square root of n. The square root of n. This is how you compute. And n minus 1 here is the degrees of freedom. N minus 1 is what? Degrees of freedom. And also with the z is also s bar minus mu all over standard deviation over square root of 1. And so we are going to use this particular t-test in research methods. Forget about the z now. So you know after when you use this formula, you are going to find what your t computed or t calculated. Then you use a table to find what t critical. Then compare the two. You get it. So this one is another second step. It's actually under the second step. It's under the second step. So and also your alpha. Normally alpha in this course, if it's not given, take it to be 5%. 5%. And with this one, the table that they are going to give you, they've done it 1 tail and 2 tail tests. So nowadays, even if your question is equal sign, After formulating your noun and alternative, you got equal sign. Hello, can you hear me?
Yeah, I can hear you.
So perhaps we did in quantity, when we get equal sign, it means you are going to divide the alpha by 2. So if the alpha is 0.05 and it's equal to, the alpha should be 0.025. But this time around, they've done it already on the slide. So even if it is 1 tail or 2 tails, don't divide the alpha. Maintain the alpha as it is.
Okay. So no matter the tail test it is, you don't divide the alpha.
You don't divide the alpha because the table that they will be given to you, they've done a column for 2 tail and column for 1 tail. You get it?
Yeah.
Let's move on to step 3. Step 3. I think that determine your p value. P value, that is what the probability of t test. So the p value is actually a probability of your test statistic. Okay. Then step 4. Are you here?
Yeah.
So step 4, you take a decision what? Conclude. Take a decision. Give your conclusion and conclude. Right? Take a decision and conclude. Now, we have 2 approaches in determining or making our decisions. So we have the critical approach and what? The p-value approach. So let's explain the critical value approach. Okay. So with this one, the decision rule is saying that for the critical value approach, you will solve for your t computed, that is this one, and your t calculated. T calculated is the formula here, and the t critical is the, you use the alpha to search for that. Use the alpha and the degrees of freedom to search for that. The t critical. Then you will solve for t calculated. Now that this is a decision rule under what? Critical value approach. Decision rule. So the decision rule is saying that reject A2. In other words, reject non-hypothesis. If t calculated is greater than what? T critical value. Otherwise, we fail to reject. Fail to reject it. So if you solve examples and you don't have, not today. So if your t using this formula, the t that you got is greater than what? Your t critical. And the t critical, you're going to use the alpha value given and your degrees of freedom to track that one on the table. Now I'm saying if it is even 2 tail test, which is the equal sign, don't divide it. Don't divide it by 2, leave it like that. You get it. Now let's look at the second approach. That's the p-value approach. And I told you the p-value is simply the profit of what? Okay, sorry. P-value is the what? Probability of the test statistic. So p-value approach. So that one, the decision rule is this. It's the opposite of the critical value approach. So decision rule for. So this one is saying reject HO. Reject HO if T calculated is actually less than T critical. T critical. So this one to reject HO if T calculated is what? Oh, sorry. This one is p-value approach. I was still writing the critical value approach here. Sorry for that. So this p-value approach, the decision rule is saying that reject HO if p-value, that's the probability of the test statistic, is actually less than alpha. Otherwise, fail to reject. Fail to reject. Okay. Then lastly, you conclude. You give your conclusion. Hello, Aggie. The rest, some are left. Hello. Hello. Do you have any question? Do you have any question for me? Because this is the end of today's session. You meet next time. The next time you meet, you are going to solve questions. That is the hypothesis, the one sample. We're going to formulate our hypothesis and solve them. Then when we finish, we solve one or two or three practical questions and move on. If you guys are not having questions for me, and it's a bye. Good night. Thank you for your time. And don't forget to share, comment, like, and subscribe to this channel. Let's up. All right.